Okay, last class we introduced you to some of the vocabulary on points, lines, and planes. But this time we're going to bring about some new vocabulary, but also the concepts that are presented are going to be applied with using algebra. So we'll start by talking about symbolic form for segment AB. We learned this last class. If I'm talking about a segment AB, I would write that with two letters, and then I would put what's called a segment bar on top of those two letters. There's also a time where you're just going to see AB without the two letters, or without the segment bar on top. If you see it without the segment bar on top, it means we want the measure of a segment. So if I say find AB, you would give me a number, meaning you would tell me the distance of the segment. So let's say I had a segment here, AB, and I had a 5 on top of it. That means that AB is equal to 5. When segments have the same measure, they're called congruent. Congruent segments are equal to each other. So the symbol that we use looks like an equal sign, but it has the tilde on top. That's the symbol for congruent segments. It's also going to be for any congruent angles, congruent circles, anything that's congruent. If you have a line segment that's on a number line, you could find the distance by counting. So if I wanted to find the distance of AB, I could just count from A to B and say 1, 2, 3, 4, 5, 6, 7, 8, 9. But later on, the numbers are going to get so big that it would take you forever to count on the number line. So the formula that we use to find distance on a number line is we take the absolute value of the difference of the two values. So here we have -6, -5, -4, and this point would be 5. So we're going to take the absolute value of point A, which is -4, and subtract from it point B, which is +5. That's going to give us a -9. But distance is never negative. I would never tell you to run -10 miles. I would tell you to run 10 miles. We represent distance using a positive number. So that's what the absolute value does for us. It takes our distance and makes it a positive value. So we have a distance of 9 on the number line. Okay, so I'd like for you to pause the video and try the next example, find RS. Okay, and you should have gotten that RS is 11. If you didn't, raise your hand or ask a friend. Okay, a word that you're going to hear quite often is called a postulate. And a postulate is a rule that is accepted as true. For example, we have the ruler postulate. And the ruler postulate says you can measure length with a ruler. And I often refer to postulates as the no-does because they're pretty obvious. You don't have to prove it to know that it's true, and they are pretty obvious that they're true. That's a word that you're going to hear a lot. Now, a rule that you have to prove is called a theorem. And a theorem is something like when we get into proving that two angles are congruent or that two segments are congruent, we have to prove them, and we'll create a theorem. And we'll work with that a little bit later on. The segment addition postulate is a really big one, and it's going to sound really complicated, but once again, it's just a no-duh. It's just a simple rule that is there to follow, and it makes sense. It makes logical sense that we follow it. So a segment addition postulate, let's just say that you had a segment PQR. The segment addition postulate, it says that if Q, a point Q, is in between another set of 2 points, then we can say PQ plus QR equals the whole thing PR. I'll put it in numbers so it makes a little bit more sense. If PQ were 5 and QR were 2, then the whole thing, 5 plus 2, would equal PR. So the whole length of segment PR is equal to the 2 parts made up of the segment PR. So the way I remember it is part of a segment plus the other part of a segment equals the whole segment. So part plus part equals the whole thing. So to see that in action, we have collinear points. DE is 2. We always label our picture. EF is 3. DE equals FG. So if DE equals FG, then FG is also 2. So FG we just said was 2. DF is from here all the way to here. So segment addition postulate would be DE plus EF makes up the whole thing, DF. 5. Okay, so pause the video and try to see if you can figure out the next two. When you unpause it, I'll have the next two answers up. Okay, check your work, make sure you got those answers. If not, raise your hand or ask a friend. Okay, so now we're going to take the segment addition postulate and we're going to apply it algebraically. So if we want to find the value of x and then the length of each segment, we're going to set up our segment addition postulate. But we have to read first. It says if JL, that means the whole thing here, is 19. Find the value of each of the following. So the algebraic equation we're going to set up is, remember, part plus part equals the whole thing. So I take part of the big segment, JK, x plus 3, plus the other part of the big segment, KL, 2x minus 5, and I set that equal to the whole thing, which is from J to L, 19. My first step would be to combine like terms, x and 2x, which is 3x, and a positive 3 and a negative 5, 3 minus 5, which is negative 2, that equals 19. I would then add 2 to both sides of my equation. So 3x equals 21. And I would divide both sides by 3. So x would be 7. The next thing you're going to want to do is figure out what the length of JK is. So if JK is x plus 3, that would be 7 plus 3, which is 10. And then KL would be 2 times x, which is 7. So 2 times 7 minus 5. 14 minus 5 is 9. And then always check your work. Does your original equation, this segment 10 plus this segment 9, does it equal the whole thing, 19? And it does. Okay, so next we're just going to draw a sketch of the collinear points. Collinear means points that lie on the same line. And then we're going to write the segment addition postulate that follows. So if we have a segment between a point A that's in between P and Q, I would start by drawing a point, labeling it A, and it's got to be in between points P and Q. And of course this is a segment, so we're going to attempt to draw a straight line. And then the segment addition postulate says part, so PA, plus part AQ equals the whole thing, PQ. Alright, so I'd like for you to try number 6. I would like to see a picture of the segment and then the segment addition postulate that follows. Pause the video to see if you get what I get. Okay, and your picture should look similar to this, with M in between H and A, and then the segment addition postulate set up like this. Okay, so for number 7, we're going to suppose that J is in between H and K, and then we're going to fill in the measures that they gave us. So they said HJ is 2x plus 4. They said JK is 3x plus 3. And then they said KH is 22. So from K to H is 22. Okay, so segment addition postulate we're going to use to solve for x. So segment addition postulate says HJ plus JK equals HK. So I set up the segment addition postulate here, and I would write in what each value is. HJ was 2x plus 4. Plus JK, which is 3x plus 3. And that equals HK, which is from here to here, which is 22. Alright, so now I'd like for you to pause the video, solve for x, and then once you've done that, substitute that value back in to find hj. Pause your video and see if you get what I get. Alright, so we should have gotten that x is 3 and hj is 10. If that's not the answer you've got to let me know and we can work on it together. Alright, example 8. From scratch, I want you to draw the picture, set up the algebraic equation, tell me what you get for x, and then what you get for hj. Pause your video and unpause it after you've done all of those required tasks. Okay, so you should have gotten x is 11 and hj is 52. If you didn't get that, please raise your hand. Okay, the next vocab word is called a midpoint, and a midpoint is directly in the middle of a line segment. It's going to divide that line segment into two equal segments, or two congruent segments. And the way that you'll know if a point is in the middle is you'll see two marks. They're called hash marks. So if I were to mark, let's call this A and let's call this B. If I were to mark this picture like this with the two hash marks, that means that AM is congruent to MB. And these are segments. A segment bisector, bisect means to cut in half. A segment bisector is a line, ray, or segment. So this could be a segment that cuts another segment in half. So if this is a segment bisector, then these two parts are congruent. I'll call that A, M, and B. So once again, AM would be congruent to MB. So now we're going to use that vocabulary to help us with our algebra. We're no longer going to do the segment addition postulate. We're talking about M being the midpoint of segment AB. So first I'm going to draw a segment AB with M in the middle. And the way I'm going to show that AM is the same as MB is I'm going to put two little hash marks there to show that AM is congruent to MB. Then they tell us that AM is 3x plus 4. So I'm just going to label AM as 3x plus 4. MB, they tell us, is x plus 20. Find the value of x, AM, MB, and AB. Well, in this one, we can't use segment addition postulate because we don't have the whole thing. The only thing we know is that AM is equal to MB because M is the midpoint. So that's the concept I'm going to use to apply algebra to this equation. So AM is 3x plus 4 and MB is x plus 20. I'm going to subtract x from both sides, so I'm going to get 2x plus 4 equals 20. I'm going to subtract 4 from both sides, so I'm going to get, bring this up here, I'm going to get 2x equals 16. Divide by 2, then my x is 8. That gives me my x value. I want to find AM. Well, AM is 3 times x plus 4, so that's 24 plus 4. So AM is 28. And because these are supposed to have been congruent, when I find MB, it should also equal 28. So x plus 20, 8 plus 20. So MB is also 28. And then finally, AB, my whole thing, is 28 here plus 28 here, which is 56. So AB is 56. Okay, and the last example, I want you to draw the picture, set it all up, solve your algebraic equation. It's going to look a little bit different than the previous example. And then unpause the video to see if you get what I get. Okay, and for your final answers, you should have gotten x is 28. AM and MB should be congruent to each other, and they're both 26, and so AB is 52. Now that one was a little bit challenging and it was different than the previous one, so raise your hand if you did not get that answer. Alright, you're ready to move on to your exit quiz.